So now we're going to do the part 2, which will be applying the lateral loads on the same moment frame. This is the same problem, but we're just solving it for lateral loads. Moment frame means these columns' stability against the lateral loads is with the connections, through the connections to the girders and horizontal beams that are connected to the other columns. So here we have two loads, again, two forces of 100 kips. I'm going to apply them. In order to do that, we're going to create a new basic load case as wind. And then apply it. We're going to create it as wind. It's in X direction, and it's positive, so I'm going to plug in 1. Its direction is going to be, its category will be wind load. Okay. Now in load combinations, I'm going to create a new load combination. It's going to be just wind, assuming that this is just a lateral column, it's not a gravity column. Now I'm going to create the force, which is going to be a joint load or a force or a point load, doesn't matter, you can give it the same location. Then specify this is a load in direction X, and its magnitude is hundreds, and its type is 103. So these are the joints that we apply that on. And then, so this is the load. Now we can analyze to see how is going to be the stability of the structure against these loads. Again, because it's moment frame, you don't have to change this. So that means the it's why end releases are fully fixed. That means these both ends, they're fixed. There's no rigid flexibility there. So we're not going to touch that, and just we're going to run it. Run it for the wind load, solve. Now I'm going to plot deflections for this load, right? For this load. If I go back to the XY direction, I'm going to reanalyze this because I think I made a mistake. Wind. So that is our deflected frame. As you see, you can bring it out either here or just go to the plot options here and then specify the deflection diagrams, magnitude, and so here we see that magnification factor equals 40. So I'm just going to make it a little bit smaller, 20 times. So whatever you see here is 20 times exaggerated, greater. That's the scale factor. And then we can go over the joint deflections as well. See, in joint N5 we have the maximum deflection of 7.8 inches. This is significant, and that means this structure will fail. Okay, so we can plot this either here or just go to the results and then results and see it. So that's the joint deflections that you're asked to do in part 2. Now we're going to change our members connections. Members means beams to the columns, right? I'm going to go to the connection of the beams to the columns and make them not rigid but just simple connection. Okay, we're going to make those bending moment released on both ends. Either here or just go to the spreadsheets and do that. Members, and then advanced, and I and J releases for the members that are beams. You can make them bending release. That means it's like pinned connection. Alright, so what members are those? I can again make the labels and see it, M5 and M6. Don't make sure that these are rigid because columns have to be able to transfer the whole loads into the foundation. So we're going to leave it there. Go back to the